So if you were in 151, we looked at LiDAR last year with a program called Fugro. It's a Fugro viewer, and usually it's free to download, does not work on a Mac, but it will open a point cloud. So I'm going to go ahead and open this point cloud of Coburg Hills. La la la. And so here is the LiDAR data for Coburg Hills, and you guys might somewhat remember that a little bit. And it symbolizes it based on elevation, so high, medium, low, and you can see the water a little bit, right? So there's very few points collected here. Some of that, if there's sediment in the water, it can reflect a little bit, but often water is just no points at all. And where is my, oh, it's over here. So I'm going to do the side profile here. Or not. I can't tell if it's thinking. There we go. There you go. Yeah. So there's the profile. Oh man, what a good bridge shot. So this is what in forestry, trying to look at what the canopy cover is. You can distinguish between deciduous and conifer using LiDAR. It doesn't get better than that, you know. So this is a nice little viewer to take a look at your data before you even start with your LiDAR data. So that's the LiDAR viewer. In Arcmap, so I'm going to go ahead and open up Arcmap. I'm wondering if I can put, okay. Oh, guess what I didn't do? Yeah, I know. What did I not do? Let's take a look. Let's hope that's it. If not, I'm going to be really not happy. I'm turning that off. Let's see. File, map, document, property. Yep, I didn't store relative path names. Okay, so I'm going to try to map to that last data set. So it's really easy to create a last data set. You just go right, new, and you can't see that because I made my window too small. New, and you get the last data set. So you can create a last data set like that, and once you get your last data set, you can add your last files, and I wanted to add, not those, by the way, I wanted to add the one from Coburg Hills, and there they are. So I'm going to add my points from the Coburg Hills, and one of the things you need to do with a last data set is calculate your statistics, and I've already done that, but if there's nothing showing up in your statistics file, you need to click calculate. And so this tells me that there are 12 million points on my first return, and there are 555,000 or 55,000 points on my fourth return. It gives me the minimum elevation and the maximum elevation with my first return, and the minimum and the maximum with my fourth return. And it makes sense that my fourth return, which is my ground level, is not as high as my first return, right? So that's getting the ground level. So it gives me that. The other thing that's really important is to know the point spacing. So this is the average distance between points in my last file. So 0.93923 something, right? And how am I going to know what the something is? I'm going to look. The linear unit is feet. So it's 0.9 feet apart, these points, right, that I'm getting, right? So not quite 1 foot is the distance between the points. So yes, I want to save those changes, and then I can just add my last data set here, and there's my last data of the Coburg Hills. If if I'm really zoomed out, this may come in as what they call a wireframe. So it just shows a red line with no data in it. And you need to zoom in here to be able to see those points. So there's my last points. And then she'll have you go in and turn on the last data set toolbar. And the data set, the toolbar here, lets you decide, do you want to look at this by classes? And they only had 2 classes. They had unassigned and ground. So I have my ground classes and my unassigned classes. This was not well classified. I can look at it by returns. So this gives me my first, my second, my third, and my fourth return. And then I can look at the filters. So let's say I want to just look at the ground returns. Okay? So now I'm filtering only the ground returns here. This has a 3D tool and a profile tool that crash my machine every time I run it. So you can look at it and know that it's going to crash. Okay, so she's going to have you just look at this data and make a few, I think she's got a small enough size that you won't have as many crashes as I did with this Coburg Hills data. But that's just the visualization part of this. So how did I figure out how to, I'm going to undo that and I'm going to see if I can repair all of this data here. See if it would repair everything. There we go. Wow, I didn't like it. Okay. So I took my data and I had it set to the returns, and the filter was set to the first return. Filter, first return. And returns, there we go. So I had it set to first return, and so I wanted to create a DEM like this of just the first returns, which means the top of the canopy. And so I set that to first return, and then I went into the Arc toolbox, and I went into conversion to raster, last data set to raster. And I put that last data set in there. Now the filter's been set, so it's only going to create that upper level canopy DEM with my with those filtered points. And I'm going to call this first return number 2. And then what's critical here is setting up the grid size for my points. And so the rule of thumb is you want your sample value to be 4 times your spacing. And my spacing was 0.9, so I'm just going to call it 4 for my sample value. And I'm going to say OK. And this thing is going to crunch and crunch. And it's going to create this DEM of my first return. So then I went through and I created a DEM of my last return, right? All right, this is not a DEM, that's the digital surface model, that's the DSM. And then I went through and I selected just my last return and my grounds. And from that, then I went to the conversion and I created my ground DEM. And from my ground DEM, I created a hillshade. And then, in order to get the canopy or the canopy height, I used the raster calculator and I subtracted my digital surface model and my DEM. So I went in here to, where's my raster calculator? It's under Spatial Analyst, Map Algebra, Raster Calculator. And I put in my that minus my ground. And then that gave me my canopy. So that gave me my canopy height. Okay. And so, so this is the output of my, oops, zoom to layer, here we go. So that's the output of my canopy heights, which looks pretty uninspiring. But if I look at this in Arcscene, so I'm going to open up Arcscene, which I do think I set relative pathways to. There's Arcscene. Okay. And so this is what I got out of Arcscene for the height of things. And Arcscene, when I set this up, I added that NDSM, surface model canopy type, and I went into my properties, and under base height, I used the base height of this surface model to extrude that. So then I've got kind of a look. So what I notice here is that I can kind of tell trees from this, right? I mean, it looks, other than the road here, the bridge is kind of messing me up. But overall, oh, and I've got a power line right here going through there. And something there. I'd have to look at that on an air photo. So, what? Maybe. Maybe that's the overpass. Good thinking. It could be, yeah. And then, yeah, there's some stuff here. So I've got, I think I extracted that canopy from this. However, my problem now is how do I get rid of the bridge and the other pieces? So I played around with the different elevations. And is this the one I symbolized? Yeah. So I took this one and I said, what if I didn't include this level elevation? Am I getting just the trees here? So I played around with just looking at what did that look like. Oh, then my roads pop back in, but it's got more trees. So what I'm trying to do is eliminate the ground surface from the tree height here. So once I played around with that, I then converted this from a raster to a polygon. So there is my polygon I created. And when I created it from a raster to a polygon, I chose to save it as an integer rather than a float, because as an integer, I have the attribute table that I can look at now. No, when I created the DEM, I created it as an integer so I could look at the attribute table. And so once I created as a polygon, the grid code is the elevation. So here are my elevation values. And so I went through and I said, okay, what if I got rid of everything between 1 foot and 10 foot? Am I left with kind of canopy cover on here? And so now, if I wanted to send somebody the canopy file, I could just select all of the values 11 foot and over and say, I think this is your canopy. And I went back through then and added the base map and played around with what was my elimination values. How deep did I want to go? And you can kind of see that I'm catching a lot of the trees up in here. And I did miss this mode field. I'm missing the quarry. It's not picking up the quarry. There's the trees around Armitage Park, but not the field. So it's not too shabby, I think, as a way to get the canopy cover. Now, what you would have to do is to go in and, go in and select these points. Now, there was a way, and I don't remember how to do this. Oh, you're right, Corey, look at that. It looks like it goes right over I-5. One way that people differentiate between houses and roads is the change from one cell to the next. So a tree is going to have a lot of change in elevation from one cell to the next, but a road is not, or a housetop is not. And so there was an algorithm that we used once to look at every single cell and say, if there's not a lot of change like you would expect from treetop to next canopy or leaf, then eliminate it. And it would really clean this up a lot. But I think for the skills that we have at this point, you could easily go into your polygon file, select those, and delete them. And get a fairly decent percent of canopy in a region. So this is definitely one of the possible project ideas that you can do. So what you're doing this week, I'm going to stop that because